Welcome to Online Vaccination Science Resources for COVID-19 Education. My name is Davida Smith and I am an Associate Professor of Natural Sciences at Eugene Lang College of Liberal Arts at the New School in New York City. This presentation is the third in a series of 4 presentations aimed at introducing you to science. This particular presentation will focus on the power and limitations of science. Having observed this presentation and completed the homework, students will be able to describe using examples the power and limits of science. Students will also be able to recognize the value of science to society while acknowledging the limitations of the process as a human endeavour. Let's review our understanding of science. Science is above all else, at its core, a process, an ongoing process that involves the scientific method. The goal of science is to understand the natural world, and by explaining it. The natural world includes all the components of the physical universe, such as atoms, plants, ecosystems, animals, communities, galaxies, etc., as well as the forces at work on those things. Supernatural elements that are not of this world cannot be investigated by science. Ideas drawn from observation and data give rise to testable claims or hypotheses, which then give rise to experiments. Testing involves finding out what one would expect to observe if an idea were correct, and comparing that expectation to what one actually observes. The product of experimentation is evidence that can then be used to either support or refute a scientific idea or claim. Science is powerful, but science is also limited and subject to challenges. When antibiotics were first introduced, they revolutionized medicine. But their use led to an emergence of antibiotic resistance, one of the most pressing challenges of our time. The scientific community is hard at work to tackle this now global issue. Reflecting on the power and limits of science will allow us to understand what science can do and what science can't do. Our institutions have stated that we need to ensure that students understand what science is and what science isn't. The National Research Council has stated that students should develop an understanding of what science is and what science is not, what science can do and what science cannot do, and how science contributes to culture. The National Science Foundation says that every student should be presented an opportunity to understand what science is and is not. And the American Association for the Advancement of Science says that the issue is a critical component of science literacy. Being liberally educated requires an awareness not only of the power of scientific knowledge, but also of its limitations. And learning these limitations should be a goal of all science courses. Knowing what science is and what isn't allows us to build trust in science. The scientific process is built on a foundation of trust. Scientists trust that the results reported by others are valid. Scientists trust in the process. Society trusts that the results of research reflect an honest attempt to describe the world with unbiased accuracy. The process of science helps us make progress. It increases our understanding of the natural world. It helps us generate knowledge. And transformative technology. It limits itself to investigations of the observable natural world. And thus science can help us understand what's real and what isn't, what's true and what's not true. It can also help us determine what works, what doesn't, for whom, and under what circumstances. The scientific method requires scientists to defend their work. They have to be able to stand behind it. While scientists can often be resistant to new ideas, just like anyone can be, the process of science ensures that over time, good ideas and theories will prevail. A valid scientific theory is predictive, verifiable, and reproducible. And as new data and evidence emerges, theories can change, adapt, and evolve. This slide shows many examples of what science has done for us. It generates new knowledge and drives new technology and technological advances. This knowledge can then be used to inform policy and solve problems such as infectious disease, climate change, food insecurity, the impact of new technologies on our society, antibiotic resistance, and diseases such as Alzheimer's. As science is based on observations, science can only deal with things that can be observed. And while we can make inferences with data, we can't necessarily always observe things with our own eyes. As our technology advances, the unobservable can become observable. And here's a wonderful example. Advances in technology can help advance science. Our ancestors believed that bad air was responsible for diseases, and a disbalance in the humours made us sick. As microscopes were developed, we were able to first see cells, then cellular motion, and then eventually molecular structures as we developed electron microscopes. We now know that viruses often linger in this bad air, and it is the virus that is responsible for diseases such as the COVID-19 pandemic. As a human endeavour, the process is flawed, as we are flawed. Sometimes human observations can be flawed. In the past, people actually believed that the shape of our heads could determine our personalities. Nobody really believes this today. The idea was called phrenology, and it was developed by a German physician called Franz Joseph Gall in 1796. It was hugely popular in the 19th century. Today, we remember it as being misused in support of racist and sexist stereotypes. It was used by the Nazis in their eugenics program. It was, however, never subjected to rigorous scientific testing. A recent paper used 21st century technology to get at the core of phrenology and found no basis for the idea whatsoever. The study argued convincingly against the idea that local scalp curvature can be used to infer brain function in the healthy population. Given the thoroughness of this study, it is unlikely that more scalp data would yield significant effects, thus proving the fallacy of phrenology. While the scientific method is unbiased and objective, scientists themselves are not unbiased and objective. We know now that bias in STEM can be implicit and explicit. It's been recognised as a critical threat to the progress of science and justice for our society. While much of the focus has been placed on looking within the individual, our institutions are beginning to attempt to remedy the systemic racism that is widespread throughout. Today's challenges, from pandemics to climate change, cannot be separated from environmental, social, and racial justice. These challenges will require rigorous, innovative, and team science-driven solutions. We know that diverse teams produce better solutions, owing to the wide range of perspectives. By increasing diversity in our labs, departments, committees, and institutions, we will strengthen our science and increase our understanding of the natural world. Bias can manifest itself in many ways. Children still draw scientists as males, often white males, and major efforts are underway to try and change that perception of scientists. Conferences have long been lambasted for not having diverse enough speakers and presenters, and major inequity in gender. Women still lag behind their male counterparts with respect to senior author positions on papers. And even during their training, women and underrepresented minorities often lag behind their white male peers in paper submissions. But it is changing. When asked, my niece did manage to draw a curiously red-haired scientist when asked to draw a red-haired scientist, which is adorable. But the existing bias in STEM is festering during the pandemic. It's getting worse. Lockdowns have reduced the capacity of women to commit to their lab work or their research work because of the demands of homeschooling, parenting, and other caring duties. We know that women are already underrepresented in areas of scientific research. It's also becoming clear that issues of relevance to women are often similarly underrepresented in the literature. We note that during peer review, COVID-19 research papers could be just as likely to be subject to gender bias as any other papers during the process. And studies have shown now that only 1 in 3 COVID-19 research authors are women, and even fewer are senior authors. So one of the things that's really important to understand is that science can also not make value statements. It's objective, so it can't make value statements. Science cannot make value statements about such things as should animals have rights, should plants have rights, what rights should people have, and should people have the right to choose if they're vaccinated or not. So science and the products of science can help us make recommendations and suggestions on the basis of data and evidence. Another way to look at things is that science can help us draw conclusions about the natural world because it helps us make statements about the natural world. But the types of statements that science make are rarely universal. They cannot be applied everywhere all the time. And we've already encountered some of these kinds of statements. If you think about it, if you were to study bird flight, you would suggest that you see birds flying, therefore all birds fly. But we know that's not true because many birds don't fly. We also know that, for example, male birds have predominantly been studied from the literature. These were birds in the northern hemisphere. This would lead people to infer that only male birds sing, because we've only seen male birds singing. But recent studies have shown that female birds also sing, as we increase the diversity of the researchers involved in birdsong research and also expand the research to cover the southern hemisphere as well. Another example is with respect to answers. While science can provide answers, science cannot ever provide final answers. And this is because of the fundamental nature of science. Science is tentative. Nothing in science is final as we increase our understanding of the natural world. As we increase our understanding, it only leads to more questions and new directions to follow, new experiments to perform, and new questions in the research environment to follow up on. And so this is a great way to consider this, is that there are many things that science cannot answer, and we know that they cannot answer them yet, but we know right now we cannot answer them. So for example, can we travel through time? How did life begin? Is the universe infinite? Do animals have souls? Are we alone in the universe? Is reality real? And what happens to you when you die? Probably better to say what happens to your soul or your consciousness when you die. Okay, so final thoughts. If we were to sum this up, for each limitation attributed to science, there's power in the process. And while you don't necessarily have to trust individual scientists, you can trust in the process of science. Science is of immense value to society, while it has limitations because it is a human endeavour like most other things. And there are many things that science cannot do. And that will conclude our third presentation in our series of Introduction to Science. Thank you for listening.